let's get started. So basically, the whole purpose of this talk is about how to avoid duplicates when using SCIO in Scala and using a specific HTTP client. So I'm using the state and pattern, state and timer pattern. So let's kick off. So I'm going to start with an introduction, and then we're going to go through a bit of the problem statement, and then the initial assessment and design. And the three main points is regarding the implementation about the StateBaseAsyncDoFn.java function, the HTTP client we're using, and the StateBaseAsyncDoFn function with a retry that we were inspired. Then a bit of testing and conclusions. So about me, I'm from Spain and I'm working in Deutsche Bank. I'm a technical leader, a bit of like a DevOps or architecture profile. And yeah, I started using C++ and then transitioning into big data distributed frameworks, so doing a lot of Scala and Spark. And I've been doing Beam for the last 2 years. And that's pretty much about me. So let's get started with the introduction here. So basically, the whole purpose of the talk is about a successful migration. So we had a microservice on Spring. It's a common use case. We're reading from a Kafka topic, and then we're delivering some notifications. What happens? That clients don't want to have duplicate push notifications in their phones because they can think, okay, what's going on? I've been charged twice. So in order to avoid that, we have to control the idempotency of the messages or the notifications we're using and we're sending to the client. So this is pretty much the legacy application. Tomorrow, I have another talk about the entire flow pipeline in bank industry we're using for sending notifications. So if you want to come over, you can take a look at it because this is the final part of the notification pipeline we're using. So let's get started. So we have like a messenger pigeon. We're reading from Kafka, a notification for a client. It could be a credit debit transaction. Then that's going to be sent to the final client. But every time we send it, we store or we persist the state within an in-memory data grid. In this case, it was a Hazel cache cluster. It's like a Redis cache, let's say. And that's the replica. We are running, or we were running that infrastructure, the Spring application, the Hazel cache or Redis on OpenShift, like Kubernetes. And then the way to expose also those notifications that were saved with the response we're getting with the final notification, we have like a CDC mechanism to replicate to another microservice, Spring and Kafka. So we expose those notifications to analytics to see what's going on with duplication, and we will have sent. So in this case, we have it rather like a messenger pigeon. We have a magpie, which is, you have a European magpies. They have also in Australia, it's a type of like a crow. So there you go. We have this lovely crow magpie. They're very popular in the UK and Ireland. So that's going to be sent to the client. That's going to be replicated into the cluster. And that's going to be sent to Kafka to undertake the analytics later on. But we can face duplicates, do rebalances in Kafka or from previous part of the pipeline. But that's not happening because we're checking with the idempotency key. Don't send that, it's been already sent. So we expose that to analytics to check the duplicates frequency. And that's pretty much it. So that's the legacy and an introduction. So the problem statement, we had a partnership with Deutsche Bank and Google Cloud back in 2021, if I'm not wrong, 2020, yeah, 2021. And we had to deploy our new infrastructure into Google Cloud. So could be this design simplified using Google Cloud? Maybe. Could we use a distributed engine rather than using like an OpenShift Spring microservice on Kubernetes? We can use something else. Why not? And what about keeping the state? So we were thinking, of course, of Apache Beam running on Dataflow. And the thing is, we have to try to figure out what to do with HTTP request. So we need a HTTP client somehow attached to the Apache Beam application. We were thinking of using, okay, at this point, assessment, use Redis to keep a state of big table to check the idempotency with the frequency of the push notifications. And that's pretty much it. So let's go through the design. So let's summarize here some of the keywords. So we have to keep a state to take the duplications. That state doesn't have to be forever, because we know that for a week or so, it's going to be very likely to have a rebalance. That's not going to happen, or anything that's been done in the past. So we a type of like time to life TTL that you have on Redis. We need a scalability, because we can have like really high peaks, like, I don't know, like a Black Friday situation, high throughput, low latency, because it's a like near real-time solution. It's not completely real-time, it's near real-time, because as you're going to see tomorrow, it's a complex pipeline, it's not just one application. Regarding the HTTP client using, we started the assessment back in November 2024, which was last year. I don't know if you can see here, we have now the web APIs since being 252. But at that point, we decided to, it was not mature enough to consider that for sending HTTP requests and getting the responses. So that's the design and the inception. So then we were having that Hazelcast cluster, but instead of using the Hazelcast cluster, we decided to use a sort of maybe state and timer pattern to keep that idempotency. How can we achieve having the HTTP client? The way we did it, it was actually using this async-do function. What is an async-do function? We were using SCIO, the Spotify API, on Scala. I don't know if that many people are using here Scala. You can raise your hand so I can have an idea. 1, 2, 3, 4, 5. Happy days, more than I expected. So happy to share our knowledge with all the Scala lovers. You have basically on SCIO, you're going to see here, it's going to be so much money. So state and timer pattern, we were trying to use that, and the HTTP client attached to the data flow application. So let's dive into the key points we are going to cover here. The implementation of that StateBaseAsyncDoFn function, which wasn't present on SCIO, and the implementation of the HTTP client, and the way we retry in case the endpoint is offline. Okay? So why SCIO? Well, we were doing Spark for a while. We were familiar with the Scala, and this runs in the Java virtual machine. And it's a bit of like a Java SDK on steroids. We have some capabilities, some classes that could be used. In this case, as you can see here, if you check the source code of SCIO, there are very interesting classes that you can use. As you can see, you have like a WABA async function. You bring your own cache, but in case you have like a massive persistence of your notifications, it has to scale vertically. In order to use that, you need the Dataflow Prime. If I'm not wrong, that's some additional cost. Working for a bank is not always the best option, trying to go the easy path and, okay, let's scale vertically, whatever happens. So let's do it like this. So we decided to scale horizontally. So this is a bit of the background. You check the links. And as you can see here, we have the do function documentation. Take a look at it. So let's dive into the implementations. This is pretty much the high-level diagram. So let's get started. So we're reading historical notifications to load the state of previous notifications in case it restarts the application. So we load the state. We can do this in two different ways. For example, you can use a side input loading from Google Cloud Storage, or you can use PubSub to make it more event-driven, and you can just keep the state at the beginning with other consumer group. So that's the first part, loading the historical data. We're reading now have the beautiful Magpie with the messenger and the notification. And first of all, we are not taking like toxic pills or any other type of validation of the record. We're using Avro for the data modeling of the notifications, reading those business event records, BER, what you're going to see in the diagram. And then we persist that in the global window. Why we're using that in the global window? We had some issues to expose and do the join between the historical data we have on the global window, and then we have a fixed window from the Kafka or PubSub notification. So that's the way we do the joint. Then we persist with the apply key and value with the state and time pattern. We're going to see the implementation later on. and then we send a notification. So that's pretty much the flow. And these are the three parts that we're going to cover: the implementation of the state-based asynchronous function, the client, and the retries. All right. So in a nutshell, on the left-hand side on green, I will have the base asynchronous function, and that one is the original source code from SCIO. And we decided to tweak it. We are suggesting a new feature on SCIO. We're probably going to implement at the moment. Only ourselves will have it implemented. So we decide here to set by element a different TTL. That's to control customer saturation. In the future, can you imagine you have a client that is sending so many different proposals for investments? So let's slow down. Not all clients want to have that frequency. So setting a specific TTL, so it's going to be an abstract class, initial load of the state, sorry, and then the idempotent buffer. And in case it's a duplicate, we expose as an output. Regarding the process element, you can see here how we set up the state and timer. So you can check the documentation. You have a bit of the links down there. HTTP client. This approach is like bring your own HTTP client. So if you're using Java, you can use any HTTP clients. We started using the SCIO HTTP client. This is some demonstration. Let's not dive into the detail of the implementation, but basically we have here this send push with request, which is a bit hard to see on the slide, but that's the reason we can use a HTTP client using this library. But also you can use like another library like ACA if you're used to I don't know, high parallel processing backends. It's in Scala as well. So indeed, we're using at the moment in production the ACA HTTP client. So let's explore a bit of the detail. So as you can see here, it's about wrapping up the send push with a future. That's the way we're wrapping up with the async client. So you have here the send push, we get the request, and depending on the request, we wrap up the response. So this is the way we do it. This is an example using the ACA client and configuration. This is the how, and this is the key. We have to wrap it as a future. So you have like a future, and then key and value, output HTTP response, because it's going to be exposed later on PubSub. There you go, the link for the GitHub code as well. So this is the implementation of the state-based asynchronous function. Again, the way we apply this key and value state, we have it here, the sync pardo handler, and this is a bit of the configuration. And as you can see, we have different HTTP clients. We use the ACA or the SCIO. And processing the element, you have here the way we do with the send push with a future. Okay. In order to do that, this is our new developed class, the notorious StateBaseAsyncDoFn function, which is now implemented in SCIO. We have to extend it and use the future handlers for it. So this is the where are doing it. Okay. The retries, we were inspired by some talks last year about the library of SCIO to use the retry. So we encapsulate the functionality of calling the endpoint to send the HTTP request with SCIO. So if it fails, it's going to retry. It's going to retry with a backup, so it's going to be safe. About testing it, so you have some testing you can run yourself with a direct runner on the open source code. So we have one magpie and two duplicated magpies with different notifications. So it's quite straightforward to do. It's quite clean, as you can see. We advance the watermark, and then we send the two duplicates. And in order to see the whole test, you could check here how we can expect a send response with an OK, like a 200 code, and to not send the duplicates. So this is about the testing. About some stress testing that we did before going to production, we were trying to replicate some of the production live traffic. So we do, I don't know, peaks of 200,000 requests. In Spain, we don't have that many clients yet, but it's going to scale. So we have to have that elasticity. So the fact that we can keep track of the pressure of the notifications we're sending to the endpoint, it allows us to because in a bank you have different applications running, different departments. So we don't want to oversaturate the endpoint service that delivers the notification. So is the way we can control the client. So this is the standard ACA HTTP client. So these are some of the peaks we got and the way it is scaled using different machines. We're using a really cheap machine. Actually, we're using the A2 standard 2. We are paying around €5 a day, which is not too bad. It's really cheap. So that's the whole point. So conclusions, as I said, huge cost saving because we were able to defenestrate the whole Hazelcast cluster, not Redis, not in memory, so not keeping a state externally, but internally in data flow. And that's great. Then that other microservice to expose the notifications we send in memory data grid into PubSub to do analytics is gone because everything is living already in PubSub, so it's easier to be exposed. And data flow with a HTTP client using the state and timer pattern. And for retries, we're using SCIO. And that's pretty much all the conclusions we got here. As I said, we got a decent high throughput for notifications, and checking the reads with the state and timer is fantastic, with great horizontal scalability and ability and robustness. Future work, try to use the PubSub to load the historical, maybe do some other tasks. We'll be happy to share other clients, you know, that you have other preferences. Maybe start getting our hands dirty with a web API that is being released in Beam 252. And looking forward to take a look at this. And we will implement StateBaseAsyncDoFn for SCIO. So it's been in the backlog for as an enhancement. So kudos to other colleagues here, or the open source collaborators that we were inspired by. So thank you so much for all the summits. We were really inspired. And thank you everyone for attending.